Hey there everybody. In this video we're going to talk about the method of undetermined coefficients, or as I like to call it, making an educated guess and seeing if you can get it to work out. So let's take a look and see how this stuff works. Okay, so our first differential equation is going to be as follows. All right, so here's our differential equation. Now, remember from the previous section that in order to solve these differential equations of this form, we're first going to find the solutions to the complementary equation, where we set the right-hand side equal to 0. Okay? So first, the complementary solutions. Okay? And you get that by just setting this differential equation equal to 0 and solving it. So look back in the previous video if you don't recall that, and because I'm not going to go through the steps here. All right? And what you'll get when you solve that one are these two solutions. Okay? All right, great. So now what we need to do is we need to find the particular solution. All right? Once we find the particular solution, the general solution will be of the form will be in this form. The general solution will be the particular solution plus a linear combination of the complementary solutions. So what we're after now is the particular solution. So the particular solution, what we're going to do is we're going to make an educated guess. We're going to get that guess by looking at the right-hand side here. Okay? Now I can see that it has an e to the 3x in it. So probably my particular solution is going to have an e to the 3x. Okay? Now, is that it? I mean, maybe that'll just work. But I don't think we'll be that lucky. So let's multiply it by a function and see if we can find out what that function would have to be to make it work. Okay? So what we need to do is we're going to plug this in here, and like I said, plug it in, see what that function would have to be to make this work. So we need to compute the first and second derivatives of this to be able to plug it in. So we're going to compute those. Now, I'm going to go through this. I'm going to write these in the in a simplified form here, so you can check this on your own. So you can work that out and check it, right? This is what the derivatives will end up being. Now, I'm going to plug these in to that stuff up there. Okay? So I'm going to compute and what I'd like you to do is go ahead and do that on your own and simplify it and see what you get. All right? So you're going to plug these expressions for u in up here and see what you get. All right? So pause the video. 3, 2, 1. All right? Did you work it out? This is what you should have gotten. When you plug that stuff in and write it out in terms of u, you get this. Okay? Great. But we also know that this thing has to equal what's on the right-hand side. So let me write that down. Okay? So now I have an equation here. These two things have to be equal. Let's see if we can solve this for u. Right? Well, first thing I can do is divide both sides by e to the 3x. Right? That's a non-zero quantity, so divide through by it. Now I need to find a u that makes this work out. Well, you might take a clue from the last video. We did something very similar. And we noted that if we ever want a second order differential equation to give us a second degree polynomial, why don't we just try letting u be a second degree polynomial? Okay, so I'm going to try letting u be the polynomial a plus bx plus cx squared. And let's see if we can find the a, b, and c that would make this work. If we can find numbers a, b, and c, then we've got it. We've got our particular solution, because that'll be the u. Okay. So if I'm going to plug it in here, I need to compute the derivatives. Oop, no, the x goes away. What am I doing? Okay, it's b plus 2cx, and the second derivative, I'm going to get just 2c. Okay. Now I'm going to take this stuff, plug it in up here, and then equate those polynomials and get the values that I need for a, b, and c. We're going to get a system of equations. So pause the video and work that out. See if you get your system of equations for a, b, and c, and then solve that system. Okay, and we'll come back and compare our work. Okay, so 3, 2, 1. Okay, so here's what I do. You could just plug them in and work it out. I'm going to do it just at a distance, right, without actually plugging it all in and using up a lot of paper. I'm going to try to just eyeball it here. So I'm going to look at the x squared terms. Okay, the coefficients in front of the x squared terms have to agree. Okay, where's the only x squared term that I'm going to get out of this? The only x squared term can come from the u. It's right here, right? So I'm going to have 2 times that. So I'm going to have a 2c. And that has to equal the coefficient on this other side here. That has to equal 1. So I can already tell my first equation is going to be 2c equals 1. Then I'm going to equate the x terms. Okay, so where can I get x terms on this? Well, I'm going to get none from u double prime, right? So I don't have to worry about that. But I am going to get 1 from u prime. So I'm going to get 3 times this. So that's 6c. And then I'm going to get 2 times u. So I'm going to have 2 times b. And those coefficients have to be the coefficient on the x term, so they have to be equal to 2. Then I'm going to have my 0 degree terms, right? Well, I'm going to get 1 of them from u double prime. That's 2c. B has a 0 degree term. Sorry, u prime has a 0 degree term. It's b, right? And I'm going to have 3 times that. And then u has a 0 degree term. It's the a. So I'm going to have 2 times a. And that has to be equal to the 0 degree term over here. So that's my system of equations. All right. And when you solve that system, I can already see from the first line that I can just solve this one for c, right? c is going to be 1/2. And once you know that c is 1/2, okay, that means this is 3. Subtract it. So b is negative 1/2. Right? And then when you plug those in up here, you can solve for c. Oh, sorry, you plug those in over here, you solve for a. You'll see that a is equal to -1/4. And look, we're able to solve it. We're able to find a, b, and c. Well, that's fantastic. That means that this will be a solution if I take those coefficients on my u. So I found my particular solution. Great. So I've done it because my general solution is going to be of this form, right? So I can write down the general solution now. Okay? I'm going to write down my particular solution, which is u with this stuff plugged in, times e to the 3x, that's my particular solution, plus c1 times my first complementary solution, e to the x, plus c2 times my second complementary solution, e to the 2x. And that is our general solution. Okay? All right, let's do another one. And I want to look at this other one because it's almost the same, but it has a subtle, important difference. Okay? So, okay, our next differential equation is this one. Okay? And like I said, this is going to have a subtle difference that I want to point out to you. Okay? So the first thing we do is we find the complementary solutions. So please do that on your own. All right? So work that out. Find the complementary solutions. Pause the video. And 3, 2, 1. You should have gotten e to the x and e to the 3x as your complementary solutions. Okay, so now we're going to find the particular solution. Okay, for a particular solution, well, I see an e to the 3x over here. So just as before, I'm going to guess that my particular solution is equal to some function times e to the 3x. Okay, and it's up to us to find what this function is. Okay, well, as before, we're going to plug that in up here, so I need to compute the first and second derivatives, right? And it's the same function that we had before, so it's going to be the same thing. Okay, and then I'm going to plug those in there, and so I get when I do this and simplify, go ahead and work this out. Pause the video. 3, 2, 1. When you simplify this, you get something quite nice, but something that we're going to have to think a little bit about. All right, we get this. But on the other hand, this is equal to this guy up here. All right, so let me write that down. Ah! It's late. I'm getting... I think this is going to have to be my last video for the evening. I'm starting to make mistakes. Okay. So these things have to be equal. Now, here's the difference. Last time we said, okay, I need to get a second degree polynomial on the right, so I better use a second degree polynomial for u. But what if we do that? What's going to happen? Well, here I'm taking two derivatives, and here I'm taking one derivative. In each of the cases, when you take a derivative, the degree of the polynomial goes down by 1. All right? So there's no way I'm going to get a second degree term here, because this is going to drop the degree by 1, and this is going to drop the degree by 2. So if I plug in a second degree polynomial for u, I can't hope to get anything higher than a first degree polynomial as the output. So I can't possibly get this as my answer. So a second degree polynomial isn't good enough. We have to go up one level higher. We need a third degree polynomial. That's the only way I can get an x squared. Okay, so that's the difference here. I'm going to have to let u equal, let's see if this works, ax plus bx squared plus cx cubed. Okay, and let's compute the derivatives of this guy. Okay. All right, so I'm going to plug these into here and equate those resulting polynomials. And I will get a system of equations that I can try to solve for a, b, and c. If I'm successful at solving for a, b, and c, I will have found my particular solution. Okay, so go ahead and do that. Pause the video. Find the values of a, b, and c. 3, 2, 1. Okay, let's do this together. Let's work it out together. So notice I'm going to be matching up x squared terms, x terms, and 0 degree terms. Where are my x squared terms going to come from? Well, the only piece that has an x squared is this one, right? The u prime piece. I'm going to have 2 times u prime, so I'm going to have 2 times this. So I'm actually going to get a 6. C is my coefficient in front of x squared. And over here I have a 12. Okay, those are the only x squared terms. Now for the x terms. Where can I get x terms from? Well, I can get them from u prime, and I can get them from u double prime. U prime is multiplied by 2, so I'm going to have 2 times 2b, that's 4b. And then plus u double prime, which is 6c. And those have to, I think I made it, like when I was talking about making mistakes, because it's late, I think I made one while I was saying that. That should be a plus. So check that out. That's a plus. That should be equal to 8. Okay. And for the 0 degree terms, I'm going to get one from u prime, which is an a. I'm going to have 2 times that, so 2a. And then I'm going to get one from b. I'm going to get a 2b. And there we go. So there's my system of 3 equations, 3 unknowns. I can solve this. Well, I can see from the first equation that c has to equal 2. Once c is 2, I can see that b has to be equal to -1. And since b is -1, a has to be, from the last equation, a has to be 4. Okay. And we were able to find a, b, and c, so it worked. And so we have our function u, and we know our particular solution is going to be this polynomial with these numbers plugged in, multiplied by e to the 3x. And so that's how we write down our general, we're going to use that in our general solution. So let's do that. So I'm going to get 4x minus x squared plus 2x cubed, e to the 3x. That's my particular solution. Then add the linear combination of the complementary solutions. There it is. There's our general solution. If I were to give you initial conditions, we're guaranteed to be able to find coefficients here, C1 and C2, so that this satisfies the differential equation and those initial conditions. And that's what makes it the general solution. Okay? So that's it for this video. Hope you learned something. I'll see you in the next one.